for the question 1, which is a hospital records indicated that maternity patient stayed in the hospital for the number of days as shown in the following. Find the probability that A patient stayed exactly in 5 days. Based on the question A, which is a patient stayed exactly in 5 days. So we know we want the probability exactly in 5 days. So the formula for the probability, which is the probability of x, which is frequency divided by n. So n is the total of the frequency, which is 120 to 7, and the frequency f is frequency of the 3 to 7. So we want to the A, probability x equals to 5, equals to probability of 5, which is 56. So we go to 56 divide by 120 to 7 equals to 0.4409. That's for question 1. B, a patient stayed less than 6 days. So we through the less than 6 days, we go to the formula probability of x less than 6 days equals to. So we go to the table, we see the 5 to the 3 is less than 6. So after we get the all of the frequency, we should add of all of them, which is 15 per 127 plus 33 per 127 plus 56 per 127, and answer that we get is 103 per 100 divide by 127, and the last answer that we get is 0.8110. Next, for question C, a patient stayed more than 4 days, which is we go to the, we should underline the keyword, which is more than 4 days. And how to do question C, we should stem the formula probability of x more than 4, and we look at the table, which is more than 4, which is 5 until 7 and 56 until 5, and we added it all. So we add 56 per 127 plus 19 per 127 plus, and we 5 per 127, and we added all, and the answer should be in 80 per 127, and answer is 0.63. That's a probability for the question C. And that's all for the question 1. Question is question 2, which is based on the table below. Find the probability that an employee is a male and a college graduate. So we take the keyword, which is male and college graduate, and the formula is probability of male and graduate. College, which is male, which is 7, and the total, which is 40. So 7 divided by 40, and we get 0.175 for question 1. And B, an employee is a female and a college graduate. So the keyword is female and the college graduate, and we look at the table, which we look at the female and college graduate, and the formula, which is probability of female and college graduate. So the college graduate is 4, and the total, which is 40, which is 0.1. Next question is C, an employee is a male and not college graduate, and the keyword is male and not a college graduate, and the formula is still same, probability of male and not graduate college, which is, we look at the table, not a college graduate, which is 20, and we took at the word, which is 20 divided by 40, which is we get the answer 0.5, the probability for the question C. And D, an employee is a female and not college graduate, and the keyword is female and not college graduate. The formula is remain the same, which is probability of female and not graduate college. And we look at the table, female and not graduate college, which is 9, and the total still same 40. So 9 divided by 40, and we get 0.225. And that's the question 2. And last question is question 3. Table below show contingency table. Find the probability that a randomly selected person is A male given that he is right-handed. So the keyword is male and right-handed, and the formula for this question is probability of male given right-handed equals to probability of right-handed and male divided by probability of right-handed. So we got the table, which is right-handed 0.41 divided by the total, which is 0.86, and the answer is 0.4767. And B, left-handed given that he is a male. Left-handed and male is the keyword, and we go to the table, we take the formula is probability of left given male equals to probability of male and left-handed divided by probability of male, and the left-handed of male is 0.08 divided by the total of male, which is 0.49, and divide, and we get equals we get the answer and equals to 0.1633. And last question is a female given that she is left-handed. The keyword is female and left-handed. The formula is remain the same, but it changed a bit, which is probability of female given left-handed equals to probability of left and female divided by probability of left-handed. So we go to the table, and it is 0.06 divided by 0.14, and we get the answer is 0.4286. And that's all for question 3. Thank you.